All right, hello, Cloud Gurus. Welcome back. In this lesson, we're going to talk a bit about reducing security threats in your environment and a number of different techniques you can employ to achieve this. So, all internet operations should trust clients that are well behaved. You have to trust that clients accessing your content identify themselves accurately, or that they only use your services in the manner that you expect. But some clients are what we call bad actors. Now, I'm not talking about the kind of bad actor that you find in some lousy TV show. These bad actors are some form of malicious software. These are typically automated processes. Some might try to scrape your content for their own profit. And others might misrepresent who they are to bypass restrictions. We call these bad bots. For example, they might fake a browser's user agent. An insecure system can also fall victim to a denial of service or DOS attack, where the target is rendered unresponsive due to a flood of traffic. Successfully blocking bad actors can help reduce security threats to your systems. In addition, you can lower your overall costs because you no longer have to serve traffic to unintended audiences. So for example, let's say we've identified a bad actor out on the public internet with a known IP address. Here in the diagram, we represent that IP address as 1.2.3.4. As you learned in a previous lesson, you can use network access control lists, or NACLs, to allow or deny certain IPs or ranges of IPs into your subnet. We could do this with a combination of inbound and outbound rules. So say, for example, we want to block all traffic from this known bad actor IP 1.2.3.4. We create a new inbound NACL rule, Rule 100 here in the diagram, that'll deny all traffic from that IP. In addition to a NACL, you can also employ what's called a host-based firewall. This runs directly on your EC2 instance and can serve as yet another layer of defense against bad actors. If you're running Linux, these are software packages like firewall-d, iptables, or UFW. If you're running Windows, you'll use Windows Firewall. Now, this gets a little more complicated once you introduce an application load balancer into your environment. With an application load balancer, the incoming connection from your bad actor will terminate at the ALB itself. So your EC2 instance itself will be completely unaware of that origin IP. A host-based firewall would be ineffective in this case. One additional measure that you could take is to allow only the ALB's security group access to the EC2 security group. However, this won't completely block traffic to the ALB originating from that bad actor 1.2.3.4. We still have to use a NACL in this case. Just keep in mind, when using an ALB, the connection from that bad actor is going to terminate at the ALB, not at the EC2 instance. Let's take a look at another scenario. This one uses the Network Load Balancer, or NLB. Unlike with an ALB, with an NLB, the traffic doesn't terminate at the NLB. It passes directly through it, directly to your EC2 instance. The client IP, the IP address of that bad actor, is visible from end to end. The only countermeasure you have in this case is to use a NACL to block that IP address. Now let's go back to ALB for just a second. There's one additional countermeasure you can employ, and that's to use a web application firewall attached to your load balancer. This is what's called AWS WAF. This is a web application firewall service that lets you monitor web requests and protects your web applications from malicious requests from bad actors. You can use WAF to block or allow requests based on conditions that you specify, like the origin IP address. You can also use WAF's pre-configured protections to block common attacks like SQL injection attacks or cross-site scripting attacks. So when might you want to use WAF, and when might you want to use a NACL? Well, if you want to block common exploits like those SQL injection or cross-site scripting attacks, then you have to use WAF. WAF operates on layer 7 and can inspect that level of traffic for these types of exploits. If you want to block an IP or range of IPs, then you want to use a NACL, which operates on layer 4. So keep in mind that hackers will often use multiple IPs in different ranges to attack you. If you rely solely on NACL rules, you're going to have a hard time keeping up. So if you're operating a public web application, you really want to prefer WAF in these instances. And speaking of public web applications, you might have a configuration that involves CloudFront. So just like with the ALB, you can also attach WAF to your CloudFront distribution. And you have a couple of options here. With CloudFront, similar to ALB, is that the client's connection terminates at CloudFront. That client IP is not visible to your NACL, only the CloudFront IP is passed along to the NACL. So blocking your bad actor's IP in a NACL when sitting behind a CloudFront distribution will be ineffective. In these cases, you want to attach a WAF to your CloudFront distribution and use the IP blocking and filtering options. Additionally, if you find that you're getting abuse from a particular country, you can use CloudFront's GeoMatch feature to block that country's traffic altogether. So these are a number of options that you can use either independently or in conjunction with each other to help reduce security threats in your environment. If you have any questions, please feel free to reach out. If not, move on to the next lesson. Thanks.